All right, trust you did well on your quiz just a few moments ago. Most of the class in here did a good job on theirs also. Let's go and review, though, for your test coming up in our next lesson, lesson 14. The first thing that you better know are your special angles, your special triangles. Make sure you know that in a 30, 60, 90, across from the little 30-degree angle is the side we call x, or more commonly, we call 1. Make sure you know that across from the 90, the hypotenuse, is 2, or 2x. And make sure you know that across from the 60-degree angle is the square root of 3, or x, times the square root of 3. Make sure you know that in a 45, 45, 90, right triangle, you know that both legs could be called 1 or 1x, and the hypotenuse square root of 2, or x square root of 2. And then the new one, the 0, 90, 90 triangle. That isn't really a triangle, but we're going to treat it like it is. If there were a 0-degree angle here, then there would be a 90-degree angle here. If there were a 0-degree angle here, this would be 0, and these would match. We could call them both 1. Make sure you're familiar with that. Make sure you know your trig ratios, sine, cosine, tangent. We remember that thinking?
Yes.
And make sure you know your reciprocals. Make sure you know the reciprocal of sine is called cosecant. Make sure you know the reciprocal of cosine is secant. And make sure you know the reciprocal of tangent is cotangent. Okay, so think through those. Be able to use those on these special triangles. We had several times where I'd say, all right, you got 60 seconds. Solve these. Go. That kind of thing you need to be able to do on the test in our next lesson. Another thing that we did was I would give you a trig ratio. Maybe say the cosine of alpha is, let's just say 5 to 6. And I would want you to be able to find the other 5 trig ratios using exact values. So go and do this. At your seats, find the sine, tangent, cotangent, secant, and cosecant of alpha. Using exact values, meaning no decimals. Really best done without the calculator completely. When you finish, check your answers.
How'd you get scored?
Remember, if you know one trig ratio, you know two sides of the triangle, or at least the ratio of those two sides adjacent to hypotenuse. So, assuming it is those lengths, because we would cancel anything else anyway, we could find the opposite to be the square root of 11. From there, you just plug it in to your ratios. How many got all 5 of these correct? Ooh, questions?
I sure did wrong.
I got them all right.
Okay, you got them all?
I did a mistake trying to get the opposite. But,
What did you have?
I had 9. Trying to subtract 36 from, or
36 minus 25 is 11, not 9. So you had square root of 9, which is 3.
Mm-hmm.
Okay, all right.
I just forgot what I was doing. I just forgot how to do it.
Okay, does it make sense
Yeah,
now?
it makes sense. I could do
All right,
it.
and as needed, you can rewatch the YouTube video if you need some review on Sunday night before you come in Monday to take your test. Another thing we talked about were cofunctions. And we said, for instance, if I had the cotangent of 58 degrees, I could rewrite this in terms of the cofunction. What is the cofunction of cotangent, class? Tangent. And we said if you use cofunctions, you also must use coangles, where co means Complementary. So the complementary function of cotangent is tangent, and the complementary angle of 58 degrees, 32 degrees. So if I had the sine of 71 degrees, I could rewrite that as, write it on your paper. And what do you have, Quentin? Ooh, careful. Help. 19 degrees. And this is why I tell you, don't use calculated dice. There again, subtracting from 90, you accidentally don't borrow right or something, it happens, doesn't it? So cosine 19 degrees. What if we had the let's go with the secant of 35 degrees minus beta? How would we rewrite that in terms of the cofunction? Do it at your seats. First thing we'll do is write the cofunction class, cosecant, and then in parentheses let's put
90 minus beta.
not 90 minus beta, 90 minus 35 minus beta. And now we can simplify to get the cosecant of
5 degrees
55 plus beta.
plus
55 degrees plus beta. Just wondering what's going on next door.
No, him.
Oh, him?
You're so confident. Go secret minus 35 beta.
Oh, you're just laughing at Chris. I thought there was something happening. I heard what sounded like a drum in the next room. I was like, I guess it's funny. Maybe it just really tickles it. Okay, Chris is confident. Well, you know, at least he's confident.
More than most people.
Anyway, all right. Another thing we talked about along the same lines as cofunctions was the ability to use cofunctions to solve trig equations. So if I had the secant of, for instance, phi plus 10 degrees is equal to the cosecant of 3 phi, we can actually find phi. Solve it at your seats.
Redemption. I'm about to get it wrong again.
No, let's not change this side. I don't want to mess with a binomial of 90 minus the quantity phi plus 10. Let's leave that side
That's what you're
alone.
supposed to do?
Let's change the easy side. Let's turn this into what, Chris?
90 plus 3 feet.
The secant of 90 minus 3 phi. Always 90
I'm
minus.
still going to get the right answer though.
And on the other side, we'll keep the secant of phi plus 10 degrees. Now, technically, class, what do we do on both sides to get rid of secant? Technically, you're taking the arc secant of both sides, which is why you can cancel them. Okay? We didn't know that at the time, though. We just said cancel them, which means we also don't need parentheses. So phi plus 10 degrees will equal 90 degrees minus 3 phi. At this point, Chris?
You minus the 10 over to get 80 degrees, plus the 3 feet over to get 4 feet, and you get 20 degrees.
And phi is 20 degrees. And we had 20 degrees. All right, questions?
No.
All right, get your calculators at the ready. If I know that the tangent of gamma is 1.471, then what's gamma? Find it at your seats. If the tangent of gamma is 1.471, then what is gamma? Don't call it out because I ain't got it yet either. All right. And let's do 1 decimal place. Let's round to the tenths on this. Let's round to the tenths. And what do we get, class?
55.8.
55.8 degrees. 55.8. All right. What if I know that the cosecant of theta is 3.005? At your seats, find theta.
That's just very obnoxious.
Oh. I'm with it.
Can you take, I mean, here, what did we do to get gamma, class? Arc tangent.
Arc tangent.
So here, theoretically, we ought to take the arc cosecant, right? But problem? Ain't got no arc cosecant. So we have to first change this
Sine.
from cosecant to sine. But if we do that, we also have to change 3.005 into
1 divided by
1 over 3.005 with the reciprocal. Now we can take the arc sine. So we're going to take the arc sine of 1 over 3.005, and what do we get for our angle?
19.4.
19.4 degrees. Chris, do you need help getting that, or did you get that?
How do you do the fraction line on this?
It's just a division, is the fraction line. So 1 over 3.005. Oh, what did you just pick? We said arc sine of 1 over, you had hit second function earlier, 3.005. That's where the K came from.
What is it?
0, 5. I'm going to show you later.
Kelvin.
Nope. And there's where it is there.
Cool.
All right. Tell you what, let me give you one more for Chris's benefit in case he is stuck using that calculator on Monday. Heaven forbid. Let's suppose
Wait,
we
this is
know
a
that
Texas
the,
instrument though.
it is. Yeah, and I don't mind that one. I know how to work that one. Everything
But
I
you
can do
don't.
here, I know how to do on that. But the secant of, let's do lambda, is 8.314. Find lambda. Yeah, we have a pretty good sized angle going here. What doth we getteth, class?
83.1.
83.1 degrees. All good?
So you do arc tangent,
Not arc tangent,
or arc cosine.
arc cosine of
8.31.
1 over 8.314. Because you're doing a reciprocal. All right, let's do this. Let's find the secant of 34 degrees, 10 minutes.
Oh, God.
Find the secant of 34 degrees, 10 minutes. Yeah, let's do 3 decimal places.
Can I do that on
Thousands
this?
place. I'm sorry?
Can I do that on this one?
You can. Except this one, like Ethan's, you can actually directly enter the degrees, minutes, seconds. So what you'll do here is you'll start by, well, we can't take the secant, we can take the cosine. So we're going to start with the cosine of 34, there they are, degrees, 10, you have to tab over minutes, equals. And then you'll have to take the reciprocal of that, which is your x negative 1. So, and that gives me the answer. So it's a pain because it's like, it takes a gazillion button presses to use degrees, minutes, seconds, but you can do it. It's just a pain. But there's no real good way to convert it over to decimal degrees that I know of. All right, did we get 1.209 when we round?
Yes.
Let me give you another one, just in case you're stuck using that calculator. Find the tangent of 14 degrees, 12 seconds. 14 degrees, 12 seconds. Nice thing is no reciprocal needed this time, right? What do we get?
0.2449.
0.249, our answer. Did you get it? All right, let's do the cotangent of 13 degrees. Cotangent of 13 degrees. And what do we get?
4.331.
4.331.
And after the reciprocal?
Yeah. All right. No homework for the weekend in pre-calculus other than be ready for the test. So if that means going back and rewatching the review lesson, do that. Going back and restudying your notes, do that. But no written homework. Have a wonderful rest of your day and a wonderful weekend. Test in our next lesson together.